Right now, a silent digital execution is taking place inside your machine, hidden behind the smooth glass of your monitor and the clean interface of your operating system. You believe your computer belongs to you, that when you delete a file, it vanishes into nothingness, and that your storage space is consumed only by the applications you consciously choose to install. This is a carefully manufactured illusion designed to maintain user compliance, while a massive automated infrastructure operations network burns through your hardware's lifespan behind the scenes. Deep within the core directory structures of your drive, systems you never authorized are aggressively logging your behavior, hoarding outdated system remnants, and creating massive, protected cryptographic archives that cannot be wiped by standard cleanup software. This is not casual system bloat. This is an intentional, systemic architecture of data retention and background execution that degrades your solid-state storage, throttles your processor cycles, and creates a permanent footprint of everything you have ever executed, watched, or typed on your machine. The deception begins the very moment you press the power button and log into your modern operating system environment, crossing an invisible threshold into a complex web of unmanaged data storage. Most users are taught to look at their primary storage indicator, seeing a comfortable buffer of free gigabytes, and assume their system is operating at peak efficiency. What the mainstream technical community fails to mention is that your operating system operates on a dual reality framework: a visible front end for the user, and an invisible backend designed to serve telemetry networks, automated update rollbacks, and persistent caching mechanisms. Deep inside hidden system volumes that are actively masked from the standard file explorer, your machine is continuously generating tens of thousands of micro-allocations every single hour. These allocations manifest as deeply buried temporary logs, diagnostic tracing files, and structural metadata dumps that slowly constrict your system's operational bandwidth. Over months and years of usage, this digital sediment hardens, forming an unyielding layer of obsolete infrastructure that your processor must sift through during every single read and write cycle. Think about what that means for your hardware efficiency when every standard command must first bypass an unorganized digital graveyard before executing your actual request. To understand how this hidden ecosystem operates, one must look directly at the primary engine of background generation, known as event tracing for Windows. This subsystem is a highly sophisticated, military-grade diagnostic pipeline that captures every single state change, hardware interrupt, and software interaction occurring at the kernel level. While marketed as a benign tool for developers to diagnose system crashes, the reality of this architecture is far more invasive and resource-intensive. Every time an application opens, a network connection is established, or a peripheral device is attached, these tracing sessions record the precise microsecond of the event and commit it to binary log files hidden deep within the system administration pathways. These tracking files do not simply disappear when a session ends. Instead, they accumulate in protected folders like the System32 log repositories, growing exponentially until they consume vast swaths of high-speed storage. But here's where it gets worse. Because these files are constantly tied to active kernel handles, standard disk cleanup utilities lack the administrative permissions to touch them, leaving them to permanently occupy vital blocks on your solid-state drive, while running down your hardware's total terabytes written metric. The problem escalates drastically when we examine the structural evolution of modern operating systems as they transition toward cloud-integrated environments and forced automated feature deployments. In the current technological landscape, your machine is no longer treated as an isolated workstation, but rather as an active testing ground and delivery node for a global software network. Every time an automated update or minor system patch is pushed to your machine, the operating system triggers a massive, highly redundant process known as component store staging. This process forces the machine to retain every historical iteration of vital system files within a heavily guarded directory structure known as the WinSXS folder. The intended design is to allow your machine to roll back to a previous state if an update destabilizes the system, which sounds reasonable on the surface. What most people are not seeing, however, is that this folder almost never cleans up after itself effectively, turning your drive into a permanent repository for dead software variants that have been obsolete for years. This is not chaos. This is a highly calculated engineering compromise where your personal storage capacity is sacrificed to offset the distribution costs of a corporate update infrastructure. As you look closer at this architecture of forced retention, you discover that the system actively uses your machine as a decentralized distribution server without your explicit awareness or ongoing consent, through an intricate peer-to-peer distribution system built directly into the operating system framework, designed to share update packages with other machines across your local network and the wider internet. To facilitate this network distribution, the system allocates a hidden, highly resilient cache that hoards gigabytes of delivered update payloads long after your own machine has successfully processed them. This delivery optimization cache operates under absolute administrative stealth, hiding within deep sandbox directories that resist manual intervention. Think about the implications of this data footprint. Your expensive, high-speed storage is being weaponized to act as a free warehouse for corporate deployment data, all while generating continuous background read operations that silently steal processing performance from your active applications. And this is where everything changes, because these hidden delivery payloads are frequently coupled with broken installation fragments that fail to clear their temporary extraction paths, creating permanent phantom files that standard diagnostics will completely misreport as valid system architecture. The situation takes an even more alarming turn when we look at the modern integration of artificial intelligence processing models and predictive user experience features embedded directly into the core operating system layer. In an effort to anticipate your actions, search queries, and application choices, the system deploys a continuous indexing and semantic mapping engine that tracks your interface interactions in real time. Every search you execute, every document you preview, and every image file that passes through your system layout is indexed, cataloged, and converted into heavy database structures stored secretly within hidden application data folders. These tracking structures generate massive amounts of localized cache files, tracking metadata and tokenized behavioral history records that continuously expand in size. Even if you explicitly disable the visible front-end settings for these predictive assistants, the underlying capture services frequently continue to run in a detached, low-priority state, silently filling your drive with behavioral junk data that never gets pruned. Read that again and realize that your operating system is actively consuming its own physical resources to build a detailed, resource-heavy model of your daily workflow, transforming your storage space into a permanent mirror of your digital identity. What most technical analysts completely overlook is the deep economic and physical damage this continuous hidden file creation inflicts on modern storage hardware. In the era of traditional spinning hard drives, a few gigabytes of hidden junk files merely represented lost space and minor file fragmentation that could be reorganized via software utilities. However, modern high-speed storage relies on NAND flash memory cells, which possess a strictly finite number of program erase cycles before the physical chemistry of the drive permanently degrades and fails. Every single time your operating system secretly writes an error log, stages an unneeded delivery package, or dumps an unmanaged telemetry database to your drive, it consumes a portion of that drive's absolute operational lifespan. The constant, invisible cycle of creating, modifying, and abandoning these secret junk files means your drive is burning through its physical longevity even when your machine is sitting completely idle on your desk. According to informed sources within the hardware manufacturing sector, a significant percentage of premature solid-state drive performance degradation is directly traceable to this relentless, unoptimized background write activity generated by core operating system subsystems. The deep breakdown of this hidden ecosystem reveals that the problem extends far beyond simple automated updates and enters the realm of persistent software diagnostic hoarding. Whenever an application on your machine encounters a minor error, freezes momentarily, or closes unexpectedly, a subsystem called Windows Error Reporting immediately springs into action. This service doesn't just send a small packet of text to a remote server. It frequently generates a comprehensive snapshot of your system's volatile memory at the exact microsecond of the failure. These memory snapshots, known as crash dumps, can easily range from several hundred megabytes to multiple gigabytes for a single event, capturing the entire state of the active software environment. These massive binary dumps are quietly deposited into deeply nested, secure system directories where they remain indefinitely, long after the application has been patched or uninstalled. What the real story reveals is that your system is running a digital hoarding operation, collecting thousands of historical records of long-forgotten software glitches that serve absolutely no functional purpose for your daily computational tasks. To make matters worse, the very mechanisms designed to accelerate your day-to-day software loading performance have mutated into major engines of hidden data clutter. Consider the prefetch and sysmain architectures, subsystems designed to monitor which applications you use most frequently, and preload their components into memory for instantaneous execution. To accomplish this, the system maintains a dedicated directory filled with specialized mapping files that detail every file layout and dependency your applications touch during their startup sequences. While effective in theory, the system suffers from a complete lack of structural obsolescence management. If you download a large software suite, use it once, and completely delete it from your system, its prefetch maps and historical initialization traces remain permanently burned into your central system directories. Over time, thousands of these dead prefetch traces clutter your core data pathways, forcing the operating system to parse through an endless list of non-existent software mappings every time it attempts to optimize your active workspace. This is the ultimate technical irony. A subsystem explicitly designed to make your computer run faster ends up choking your system performance under the sheer weight of its own unmanaged historical records. The hidden architectural bloat escalates further when we look at the internal data management systems of modern web browsers and integrated web view components that are permanently welded into the operating system's user interface. Modern system menus, cloud widgets, and news feeds are no longer native, lightweight code structures. Instead, they are essentially minimized web browsers running continuously in the background. Because these interface elements rely on web deployment protocols, they generate massive, unmanaged internet cache footprints directly inside your primary system directories. Every single icon, promotional graphic, and news headline displayed in your taskbar or start menu environment downloads an absolute mirror of its web assets into highly obscured app data repositories. These folders quickly fill up with millions of tiny, fragmented files, cookies, and tracking scripts that clog the file system's allocation tables. Because these files are so small and incredibly numerous, they force your storage drive to spend an excessive amount of time processing file system entry metadata, causing a measurable drop in overall system responsiveness that standard defragmentation or optimization tools are completely powerless to address. But here is where the narrative shifts from simple operational negligence to a deliberate architecture of user obstruction. When you attempt to clear these hidden operational layers using the standard disk cleanup utilities provided within the default system settings, the software purposefully runs a highly restricted sweep that leaves the most significant data hoards entirely untouched. The default utilities are programmed to prioritize system safety and stability over user storage liberation, meaning they will actively skip over telemetry stores, component staging areas, and deep application caches to avoid disrupting background corporate data harvesting pipelines. To truly reclaim your hardware, you are forced to bypass the consumer-facing interface entirely and deploy advanced administrative deployment commands that operate directly on the underlying image management service. By invoking tools like the Deployment Image Servicing and Management Framework through an elevated administrative command line, you finally catch a glimpse of the true scale of the data suppression taking place on your machine. Only through these deep service cleanups can you force the operating system to finally purge the gigabytes of superseded component libraries and abandoned update packages that have been locked away behind artificial administrative barriers. The real danger emerges when we realize even when you execute these advanced administrative purges, you are only achieving a temporary tactical victory in an ongoing structural war for control over your own hardware platform. Within hours of executing a complete system purification, the automated background engines built into the core operating system kernel will detect the absence of these tracking databases and diagnostic structures. The system treats the cleared space as an unfulfilled operational mandate, immediately restarting the tracking daemons, reallocating the delivery optimization networks, and beginning the process of building entirely new telemetry layers from scratch. The real story is that your operating system has been fundamentally engineered to resist being clean. It views a perfectly optimized, lean file system as an anomaly that must be corrected through automated background execution loops. This means that maintaining a high-performance, clutter-free machine is no longer a one-time maintenance task, but a continuous, high-stakes operational struggle against internal software architecture that is actively working to fill its own containers at the expense of your physical hardware lifespan. Think about the hidden financial cost of this systemic design paradigm as it scales across millions of personal computers and corporate workstations around the globe. When an operating system consistently consumes 10 to 15% of a drive's total capacity and writes hundreds of gigabytes of unneeded data, every single month, it effectively forces a massive artificial acceleration of the hardware replacement cycle. Consumers and enterprises are driven to upgrade their machines, purchase larger solid-state storage solutions, and discard perfectly functional hardware because their systems have become painfully sluggish under the weight of unmanaged, invisible junk. What mainstream technical journalism labels as natural software evolution is, in reality, a catastrophic failure of basic data management principles, where the end user is forced to foot the bill for inefficient, predatory coding practices that prioritize corporate telemetry data capture over raw mechanical efficiency. The very definition of a junk file must be entirely rewritten. These are no longer accidental byproducts of minor software operations, but the structural residue of a modern computing environment that views the user's local hardware as an exploitable resource for corporate infrastructure optimization. As we plunge deeper into the complex mechanics of this hidden data architecture, we must analyze the specific, hidden storage repositories that hold the most volatile records of your daily operational existence. Among these, the most heavily guarded and deceptively designed structure is the System Volume Information Directory, a highly protected folder located at the root of every single drive partition. This directory is heavily locked down using advanced cryptographic permissions that prevent even local system administrators from opening or viewing its internal contents through standard methods. While the official documentation states that this repository is reserved exclusively for system restore points and volume shadow copies, an empirical breakdown of its data allocations reveals a much darker reality. This folder acts as a centralized vault for the storage engine's distributed tracking databases, containing massive unmapped index logs that keep track of the precise physical location and movement of every single block of data across your entire drive layout. If you shift a file from one folder to another or delete a sensitive document entirely, the structural ghost of that file transaction remains permanently etched into the transaction logs of this hidden volume, completely immune to standard file shredding or partition wiping utilities. This architectural pattern of total data retention becomes even more aggressive when we isolate the background behavior of modern integrated web browsers like Microsoft Edge, which now function as an inseparable extension of the operating system's internal core. Even if you completely ignore this browser and use alternative, privacy-centric software for your internet navigation, the integrated browser engine remains running in a suspended high-priority state directly inside your system memory. Because it is tied into the system's primary shell interface, it continuously populates hidden user profile directories with extensive telemetry caches, diagnostic crash files, and unmanaged WebView databases. Every time your computer updates its weather widget, refreshes a stock ticker, or displays a recommended article in your search menu, the background browser architecture generates hundreds of small, unindexed temporary files that never get automatically purged. These files gather in highly obscured paths inside the local app data repositories, forming a massive digital archive of internet debris that slowly degrades the file allocation tables of your storage drive, forcing the system to expend additional processing power just to index empty or obsolete directories. And this is where the situation gets significantly worse for users who believe they have successfully mitigated these problems by utilizing basic third-party cleaning utilities or running standard optimization scripts. The vast majority of consumer-grade optimization software is completely incapable of accessing or modifying these core system structures because they lack the necessary kernel-level security tokens to bypass the operating system's active protection modules. Click clean on a standard consumer utility, the software merely executes a superficial sweep of public temporary directories and empty recycling bins, giving you a false sense of security while leaving the deep structural data hoards completely untouched. Furthermore, many of these automated third-party tools use outdated or highly generalized deletion protocols that can inadvertently corrupt your system's component state, leaving behind broken registry keys and detached file pointers that actually increase system instability and cause the operating system to generate even more diagnostic error logs to document the corruption. You are left caught in a destructive feedback loop where the very tools you use to rescue your hardware end up triggering an aggressive automated defense response from the operating system. It fills your remaining space with panic dumps and system tracing reports. To break free from this cycle of structural degradation, one must understand the precise technical methods required to completely dismantle these hidden operations at the command line level, far below the restrictive limitations of the graphical user interface. The first critical line of defense involves reclaiming control over the system's component store through the aggressive deployment of the DESM command suite, specifically targeting the superseded component bases that have been abandoned by the automated update systems. By opening an elevated administrative console and executing a targeted component cleanup with the reset-based switch, you strip away the artificial protections guarding the historical remnants of old updates, forcing the system to permanently commit to its current state and release gigabytes of locked storage space that can never be recovered by standard cleaning apps. This operation directly purges the redundant code variations that have been choking your processor's internal caching paths, instantly streamlining how the operating system interacts with its core system files. However, this is merely a structural purge of software fragments. It does not stop the continuous, real-time generation of behavioral tracking logs that occurs every single second your machine remains operational. To stop the real-time hemorrhage of your storage longevity, you must target the core telemetry tracking engines that feed the continuous event logging frameworks. This requires navigating into the deep administrative frameworks of Performance Monitor and locating the hidden active startup event trace sessions that are hard-coded into the operating system's initialization protocols. These sessions, particularly the ones dedicated to application telemetry and diagnostic data collection, operate like an invisible black box recorder inside a commercial airliner, constantly streaming binary data directly to your drive's storage cells. By systematically disabling these tracing sessions and modifying their registry-level initialization keys to prevent them from automatically restarting during the next boot cycle, you effectively cut off the data supply to the secret RETL log files that slowly expand across the drive. This structural intervention completely halts the unnecessary background write operations that degrade your solid-state drive's memory cells, instantly dropping your system's idle drive utilization down to absolute zero and preserving hardware's physical integrity for your own intensive workloads. But what most people are completely blind to is the hidden presence of massive, unmanaged network deployment caches that are generated by the operating system's built-in application store and its cloud-synchronized account frameworks. Every time you download an application, update an integrated component, or sync personal settings to a cloud profile, the system creates a massive, heavily encrypted sandbox directory inside a highly restricted folder known as Program Files Windows Apps. This folder is protected by advanced security descriptors that completely block the user from even calculating its physical size through standard properties menus. Within this digital fortress, the operating system routinely leaves behind abandoned installation packages, incomplete update fragments, and heavy localization data for applications you have never opened and will never use. Because the user is entirely locked out of this directory by default, these dead assets can sit silently consuming tens of gigabytes of premium storage space for years, completely invisible to the vast majority of diagnostic tools and standard maintenance routines. Think about the sheer scale of this invisible architecture. A perfectly clean, newly installed operating system can easily generate over 20 gigabytes of completely unnecessary, highly redundant data structures within its first few months of standard consumer operation. This is an entirely unsustainable design philosophy that completely undermines the incredible engineering advancements made in modern flash storage technology. While hardware manufacturers spend hundreds of millions of dollars optimizing the read and write speeds of modern solid-state drives, the operating system developers are simultaneously creating increasingly bloated, unoptimized file tracking systems that completely cancel out these performance gains through continuous, unmanaged background data thrashing. The real story is that your computer is constantly fighting against its own software layer, spending an unacceptable amount of energy and physical wear simply processing the administrative waste generated by an operating system that no longer prioritizes mechanical efficiency or user autonomy. Look toward the future of personal and professional computing. The trajectory of these operating system architectures suggests an even more aggressive shift toward total background data accumulation and resource monopolization. With the introduction of hyper-integrated machine learning frameworks and continuous user activity capture systems that operate at the deepest sublayers of the software environment, the volume of hidden data generation is poised to expand exponentially. Future updates are designed to transform your machine into a self-contained intelligence node that is constantly analyzing, processing, and recording your physical and digital behaviors to maintain a highly personalized local model. This means that the secret junk files of tomorrow will not just be simple error logs or temporary internet graphics. They will be massive, multi-gigabyte cryptographic databases filled with tokenized representations of your voice, your typing cadences, your visual interfaces, and your real-time processing habits. The struggle to maintain a clean, high-performance machine transform from a basic hardware maintenance routine into an absolute necessity for data sovereignty and privacy. The ultimate consequence of this structural reality is that the majority of computer users are operating their high-end machines at a massive performance deficit, completely unaware that their premium hardware is being slowly throttled to death by an unyielding tide of invisible digital sediment. The sluggish boot times, the inexplicable micro-stutters during intensive gaming or video rendering workloads, and the sudden mysterious in available drive space are not signs of aging hardware. They are the direct symptoms of an operating system that is drowning in its own unmanaged data extraction pipelines. Until you take decisive, administrative control over your machine, bypass the superficial consumer-facing interfaces, and permanently dismantle the deep tracking and staging frameworks that drive this continuous file generation, your computer will never truly belong to you. It will remain a highly restricted, corporately managed asset that merely allows you to use its processing cycles while prioritizing its own hidden data hoarding agendas over operational freedom. The deeper you descend into the underlying demand structure of the operating system, the more you realize that the entire environment has been built on a foundation of systemic misdirection. Take, for instance, the hidden volume of space consumed by the Windows installer cache located within the highly obscured installer system directory. It is designed to hold an absolute duplicate copy of every single installer package and for every piece of software you've ever added to your machine. The system claims this is necessary to allow applications to be modified or uninstalled cleanly in the future. However, when an application updates itself automatically to its own internal networks, it frequently fails to notify the central installer cache to delete the previous iteration of the installer payload. This results in an incredibly chaotic accumulation of multi-gigabyte setup files for old software versions that no longer exist on your machine, locked away in a system folder that explicitly forbids manual deletion through standard user profiles. If you delete these files blindly, you risk permanently breaking the uninstallation pathways for your active programs, effectively holding your storage space hostage under the threat of system-wide software corruption. This structure of forced reliance and hidden data accumulation is further amplified by the massive deployment of the Windows Search Indexer service, an automated utility that continuously crawls through every single file, email, and metadata fragment across your storage network to provide near instantaneous search results. To maintain this lightning-fast responsiveness, the indexer compiles a highly complex monolithic file that frequently grows to an unmanageable scale, sometimes consuming upwards of 30 or 40 gigabytes of storage on systems with extensive file networks. This indexing file is constantly being written to, updated, and re-indexed every time a single character changes within a document or a temporary file is generated in the background. The continuous disk thrashing generated by this service represents one of the single greatest contributors to high active drive percentages and localized hardware latency. What most people are completely blind to is that this indexer is routinely cataloging thousands of hidden temporary files, internet cache segments, and system logs that you will never actually search for, meaning your machine is spending a massive portion of its structural processing power indexing its own internal junk data. But here is where the technical deception reaches its absolute peak. When you look at the system's integrated storage sense utility, the highly publicized automated feature designed to keep your drive clean without user intervention, you discover that it is hard-coded to completely ignore these deep systemic folders. Storage Sense is essentially a marketing gimmick designed to appease casual users by deleting the contents of the standard user recycle bin and the surface-level internet download folders every 30 days. It possesses absolutely no authority or code routines to touch the installer cache, the component store, the event tracing logs, or the hidden application sandboxes. By directing public attention toward these harmless, easily accessible user folders, the operating system successfully misdirects the conversation away from the massive, multi-gigabyte corporate telemetry and update structures that are the true culprits behind long-term hardware degradation. It creates a comforting narrative where the system appears to be actively caring for your storage health, while the true engines of data hoarding continue to run completely unhindered in the dark. Think about what this means for the global landscape of digital waste and consumer technology cycles. Millions of completely functional personal computers are discarded or upgraded every single year simply because they have become too slow to handle basic modern tasks. This slowdown is almost universally accepted by the public as the natural, inevitable aging process of digital electronics. The reality, however, is that this degradation is entirely artificial, a direct consequence of an operating system architecture that has abandoned the core principles of lightweight, efficient, and user-optimized software design. Your hardware isn't failing. It is being buried alive under a mountain of hidden administrative waste, forced to carry out thousands of unneeded background operations for every single task you attempt to perform. The true cost of your operating system is not the price of its retail license, but the continuous, stealthy destruction of your physical hardware capacity and processing performance over the lifespan of your machine. To fully reclaim your system from this state of total administrative capture, you must move beyond temporary command line cleanups and begin executing precise structural modifications to the system's core operational registry database. By navigating into the deep hives of the system initialization keys, you can manually locate and sever the execution paths of the automated diagnostic tracking daemons, such as the Universal Telemetry Client and the Diagnostic Tracking Service. These services act as the primary structural bridges between your local hardware activity and the remote corporate data collection clouds, constantly packeting your system utilization statistics, error occurrences, and application habits into heavy local databases before broadcasting them over your network. By stripping these services of their startup privileges and modifying their security descriptors to prevent the operating system from automatically reinstating them during a major update cycle, you permanently halt the creation of the massive telemetry databases that slowly choke your system's file system allocation structures. And this is where everything changes for the architecture of your system performance. Once these heavy background logging engines are permanently deactivated, the immediate physical relief on your hardware is nothing short of revolutionary. The continuous phantom read and write operations that cause your solid-state drive's activity LED to flash incessantly when the machine is idle will completely vanish. Your processor's internal cache lines will no longer be constantly flooded with diagnostic interrupt requests, allowing your active applications, games, and creative software suites to access the absolute raw potential of your physical silicon. You will experience a level of system responsiveness and interface fluidness that feels as though you have completely upgraded your core hardware components, proving that the perceived limitations of your computer were never a physical hardware bottleneck, but a direct consequence of a massive, unmanaged internal software occupation. Yet, even as you achieve this state of optimized operational freedom, you must remain hyper-vigilant against the persistent, automated attempts of the operating system to reclaim its lost territory. Modern operating systems are designed with incredibly aggressive self-healing mechanisms that treat any user-optimized modification as a form of system corruption or malware interference. During the next major feature deployment or security update cycle, the update engine will actively scan your registry keys, your system tracing configurations, and your component store settings to identify any deviations from the factory-mandated data capture protocols. If it detects that you have disabled a telemetry pipeline, purged an installer cache, or severed an indexing database, it will quietly overwrite your customizations under the guise of an automated system repair, silently rebuilding the entire apparatus of data retention without ever alerting you to the fact. This is the definitive reality of modern computing. You do not own your operating system. You are merely a tenant in a highly monitored digital estate, locked in a permanent high-stakes battle of technical attrition to maintain the performance and privacy of the hardware you paid for with your own hard-earned money. The final, unresolved question that every modern computer user must confront is whether they are truly willing to accept this paradigm of corporate hardware exploitation as the inescapable price of digital connectivity. As systems become increasingly complex, cloud-dependent, and infused with non-negotiable artificial intelligence monitoring frameworks, the space left for user autonomy and mechanical efficiency is shrinking to absolute zero. The hidden junk files you discover today are merely the early warning signs of an upcoming era where personal computing hardware will be completely subordinated to the data harvesting mandates of a handful of global technology monopolies. To ignore these hidden files is to surrender control over your most vital professional and personal tool, allowing your expensive hardware to be transformed into a slow, heavily monitored, and rapidly decaying node in a global network that does not serve your interests. The choice is no longer about simply cleaning a computer. It is about drawing a hard line in the sand and executing absolute sovereignty over the machines that define our lives, demanding that our hardware serves us, and us alone, before its physical lifespan is completely stolen away by the silent, relentless engines of hidden data accumulation.